Now let's take a look at some different ways that we can analyze distribution, frequency distributions. We're going to talk about percentiles, quartiles, Z-scores, and the empirical rules regarding symmetrical distributions, symmetric distributions, and how we can identify outliers, again, when we have symmetrical graphs, symmetrical histogram, symmetric distribution. We're going to use, whenever needed, we're going to use data file homestays. So let's just define them one by one. Percentiles are the value of a variable, a specific value, at which a specified percentage, and that percentage actually, we use that for calling the percentile. So we will have like 99 percentile, first percentile, second percentile, all the way to 99th percentile, right? The whole range would be 100%. So we can start from 1 all the way to 99. So pth percentile will tell us the value at which p% of the observations are below it, 100 minus p% above it, greater than that. When it comes to Excel, this is usually, there are two formulas, there are two ways you can find it, which are very slightly different. The difference is really minor, but this is one way, this is one popular way to find it. You can arrange the data in an ascending order. If you want to do it manually, you can sort the data from smallest to largest, and then you need to find the position of the pth percentile. For that, you just need to take this n plus 1 times the percentage, and then you just need to take the k as a decimal number. So k would have two components, an integer component and a decimal component. You can take the PS percentile would be the k plus, I plus dth observations. So so it would be between I and I plus 1. But then for finding that, for finding the exact value, you pick the i's plus the decimal factors times the difference between I plus 1s and I. I can just do one example here on data file homestays. I can do both manual and the Excel has a pre-established function for that, but we just to understand how it works, we can do manually one time and try the percentile function. So I'm just going to add percentile. But again, percentiles, there are 99 different values depending on what percentile you're looking for. So I'm going to pick a number between 1 and 100. So I'm going to pick, let's say, 65. So 65, 65th percentile. That's what I'm looking for. I'm just going to go with the manual procedure just to see how it works. And then we will use the Excel function, the percentile function. So the manual way, so we have, I'm just going to sort the data file. So smallest to largest. So 65th percentile out of 12 observations. This should be, as you can see here in the formula, n plus 1. N is 12. We have 12 observations in our data file. 12 plus 1 times point. So I would say position of 65th percentile. that would be 12 observations plus 1 times 0.65, or 65 divided by 100. 8.45, 8.45th observation here. When you start from the top, that would be your 65th percentile. So 1, 2, 3, 4, 5, 6, 7, and 8. So 8.45. So it would be so I will have 8th observation. I mean, this case happened to be the 8s and 9s, 9, 10, 11, 12. Yes, they happen to be exactly the same value. So 65th percentile would be 254,000. So because that is not, that doesn't show what we are looking for. I just changed 65 to, let's say, 45, and just go from there. So I just changed it to 45. So we're looking now for 45th percentile. For finding the position of 45th, we should just take that 12 observations plus 1 times 0.45. That gives us the position of 45th percentile. And that would be the 5th, somewhere between 5th and 6th observation. So 5th observation is 1, 2, 3, 4, 5. 6th observation is this. So 5.85. If it was 5.5, it was right at the middle of these two values. But I just need to go, this is the position of the 45th. 5, not 5, not 6, 5.85. So it's going to be 45th percentile. It's going to be 5th observation plus 0.85 is the decimal part of that number times the difference between 6th and 5th observation. So it'll basically gives us the 5.85th observation on this list. So that would be our 45th percentile. Well, you don't have to do this. When it comes to Excel, you can just use percentile. And there are two functions in Excel. Again, percentiles.exclusive. I said there are two functions, the functions that we use for position here, but the difference is very, very minor. Exclusive or inclusive. Doesn't really matter which one of these two you use. Most of the time, they're the same, and they can be slightly different. But if you want to get the same exact number as the procedure that we just defined, make sure to use the exclusive, right? Exclusive, take the array, and then K should be a number between 0 and 1. We're looking for 45th. K is the P in the notation of the book, actually. So we're looking for 45th, 0.45. That should give you exactly the same answer. So that's for percentile. Now, a specific type of percentile is called quartile. When we are just looking at not just like all the numbers from 1 to 100. If we just look at the quartile, only the 25 multipliers, like 25, 50, and 75. These three, these are called like 25th percentile, 50th percentile, or 75th percentile. Most people are, I mean, a lot of people are only interested in these percentiles. So these are the most commonly used one. So I'm just gonna, let's say, first quartile. Second quartile, by definition, is going to be equal to the median, because median is exactly the point where 50% of the observations are below it, 50% of the observations are above it. And that's just the definition of second quartile. It's just the definition of 50th percentile. So that's going to give you the same thing, third quartile. And then the function is quartile. Again, we have exclusive, inclusive. I'm going to go and go ahead and use the exclusive one. Quartile number 1. Same thing, except that it's going to be 2 and 3. All right. So that's score. By the way, for most of the items that we have regarding the location of the distribution, you can get most of them using the descriptive statistic tool in Excel, in data analysis tool pack. If you go to data tab, data analysis, before moving to the next one, let me just quickly talk about that. Descriptive statistic tool. If you just open that, input range, the values, and the grouped by column. There's no label. I didn't put the label. You can just make sure to include the first one and check the label, and then you can put it in the table. And then you just want to check this one, summary statistics, and maybe if you want to make sure to have top 5, top 2, top 3, etc., or bottom 2, bottom 3, etc. You can pick those. And confidence level, we're going to talk about this later, but this will give you most of the items that we just talked about here. That's just for your information, but you should be able to use these, and these formulas. Most of the time, you don't need to call this tool pack. You just need to write down the function and get these values. All right. The next way we can analyze distributions is through Z-scores. Z-scores, they show the relative location of each value in a data set in terms of their difference, in terms of their distance from the mean relative to the data set's standard deviation. So it shows the basically the distance of a value from the mean, from the sample or population mean, in terms of the standard deviation, the number of standard deviation. And for that, you can use the function. Let me just add one column here, and Z-score. And you can use the function standardize. Standardize, it gives you normalized value. So X mean, we already have the mean. I'm going to fix the mean, and standard deviation. All right. Mean, standard deviation, and the X. X is going to change from a value to another value, but mean and standard. Or you can type average of these values, stdev.s of these values. It's not going to change anything. But this is the function that you can use for getting the Z-score. Let me show you again the formula here. Let me insert another column. All right. That'll give you the Z-score. And Z-score tells you how the value is far from the mean in terms of the standard deviation, right? So this value is far from the center of the distribution by 2 almost 5 standard deviation, 2.5 this, right? So it shows that this value is at the right side of the distribution and it's far from the center by 2.5 standard deviation. So that's the meaning of it. And it's great when we want to, I mean, whenever we have multiple factors, you may have selling prices and they take selling prices of houses, they take large values. You may have unemployment rate, they take numbers that are below 1. If you want to compare two columns, this is usually how you can do that. You can take the z-score and that'll bring everything in the same scale. And that is a very helpful tool for comparison purposes when you have multiple factors with different units. All right. Moving on, we have two rules here. This is probably the last slide. We also talk about the box plot when we analyze the distribution. But we have one rule here, the empirical rule, and it says whenever you have a bell-shaped distribution, a symmetric distribution, a normal distribution, usually, this is by experience, 68% of the observations are within one standard deviation from the mean. Approximately 95% of the observations are within 2 sigma. Approximately almost all the data values, I mean, it's for the normal distribution is 99.7, but almost all, right? So that's just a almost everything. It's just a very minor proportion that is not included, is above 3 or below 3 standard deviations from the mean. All right, so if I want to, again, if we want to repeat again, 68% within 1 standard deviation from the mean, 95% of the observations should fall within 2 standard deviations from the mean, and almost everything should be within 3 standard deviation, between -3 standard deviation and +3 standard deviation from the mean. So if you put the mean at the center, 3 standard deviation to the left, 3 standard deviation to the right, that should cover everything. And this last one is actually the way that we can identify the outliers when we're dealing with a bell-shaped distribution. So if there is something that the z-score is the number of standard deviations that the value is far from the mean of the distribution. So if a value has a z-score above 3 or below -3, that value can be identified as an outlier. And whenever we have an outlier in a distribution, it's a tricky situation. Most of the times, I mean, always, whenever you see an outlier, you should ask yourself as an analyst, why we have an outlier here? Why is it so different from the rest of the observation? And depending on the cause of the outlier, depending on the underlying reason behind the outlier, you may act differently. So if the outlier is because of a measurement error, or there is an error, you simply remove it, or you go back and correct the error in your data set, right? If the outlier is because there is a genuine difference in the values, you may have a few observations that are really far from the rest of the observation. Again, depending on the questions that you're trying to answer, depending on the objective of your analysis, you may want to still keep them in the data set, but you should be aware that whenever you have an outlier, they may deviate the center of the basically your distribution, right? So they usually have a heavy weight because of their difference, and they always take the same weight as the other values. It's very important. Sometimes some people, some analysts, they just remove them from the, again, it depends on the objective, but sometimes some people remove them and they do a separate analysis on the outlier. So you may have a, basically a data set without outlier, and it's data set that contains the outlier. Um, you may have three. You may have a full data file, one without the outliers and one only outliers, right? And then do the analysis on each one of the three and study the impact on whatever you're actually studying, right? Next one, box plot. That's basically the last tool that we're going to talk about in terms of the analyzing the distribution. This is a graph that shows you, as you can see here, it shows you, this is a horizontal graph. Excel, we're going to see it in our example here. It's going to give you a vertical one. But as you can see, it gives you the minimum of data file, quartile one, the first quartile, median, which is also the second quartile, the third quartile, and the maximum. And if there is anything that is far from the rest of the observation, it identifies it as an outlier. It just puts it at the end and excludes it from the rest. So you see 25% of the observations are between minimum and quarter one, 25% between quarter one and median, 25% between median and quarter three, 25%, the last 25% between quarter three and maximum. And in case you have any outlier, it just identifies it as outlier and puts them at the end, at the either side. It can be at this side or at this side. So, and it gives you a very nice summary of the observation. Box plots are huge tools, are great tools when you want to compare the distribution of different populations. If I want to compare the GPA of students in this class and in another class, this is the tool that I should use, box plot. It tells me where the center of the distribution is, where the range is, the lowest 20, bottom 25%, what is the range here in this class, in the other class, and so on. How do we draw it? So I'm just going to use the selling price, and I'm gonna insert a box plot here. So if you just pick, highlight the selling price, go to the charts and pick all charts, box and whisker, and pick that. Again, I'm just doing it for one column, but if you have multiple classes, multiple samples, you can put them in different columns and highlight all these columns at the same time, and that will give you multiple box plot on the same graph, which is great for comparison again. So minimum, first quartile, second quartile, this line, the third quartile, and this cross that you can see here, it's the mean, it's the average. Third quartile, maximum, and then if there's any outlier, it just identifies it here and puts it at the end. Again, either at the bottom or at the top of your distribution.